Okay, so a last look at the half angle identities without going too far on that is we want to go ahead and look at a couple things that are related to the unit circle. So we can actually solve two different styles of problems pretty easily with these. And one of those is problems that are a pi over 8 style question. Like if someone says, what is the sine of 11, let's say pi over 8? Now, that's not necessarily a super nice number, but it'll be fine. And so I'm going to think of this instead of as 11 pi over 8, I'm thinking about it as 11 pi over 4 cut in half. Now, I do have to stop and think about something for a second. I know that 11 pi over 8 is actually down here in the third quadrant. And so I know something. I know that if we have this in the third quadrant, then I know that the sign right here should lead to a negative answer. That is something that I know to be true. But I have another little thing that I need to think about because I'm actually looking at 11 pi over 8 by thinking about this. And so 4, 8, almost 12 is sitting right here. So 11 pi over 4 is actually sitting in the second quadrant. This is kind of strange. So I'm looking at something in quadrant number 3 by thinking about it as if it was in quadrant 2. So that's, like I said, kind of strange. So the formula for the sine says 1 minus the cosine of my half angle all over 2. And so notice this negative is here because I knew that the sign was negative, so I'm carrying that negative along. Now, I know that the cosine of any kind of answer is root 2 over 2, but I know that since this is in the second quadrant, I know that the cosine itself is negative. So I'm going to subtract from the formula a negative from the unit circle. So that's kind of a double negative story. So when it's all put together, we end up with this story right here. And that does look a little bit nasty, but as it turns out, that's kind of nice because if I multiply a 2 through the numerator, I would get 2 plus root 2 because the 2's would cancel this. And 2 times 2 is 4. And of course, the square root of 4 is 2. And so that would be the end of my story. Now, keep in mind, it's always nice to double check our answers and make sure we haven't done anything silly. So the sine of 11 pi over 8 is some terrible looking decimal. I'm going to double check that I'm in radians, and I am. So that looks pretty good. Now, when I did this work before, I got that my answer was negative the square root of 2 minus root 2 all over 2, and hopefully I got the same answer, which it doesn't look like I did because I typed it in wrong. So let's try that again. Let's make this a plus in here because there was supposed to be a plus right there. Looking at my own answer, and that does give me the answer that I thought I should have from the beginning. So as long as you type things appropriately, it works well. Now, let's go ahead and go just a little bit further, and let's imagine that someone was asking me to take the secant of, let's say, pi over 12. Now, I did show you previously on how to find that using a sum and difference, but it's kind of cool that we can do it both ways. Now, keep in mind, this is in the first quadrant. So I'm going to pretend for a moment that I want to find the cosine of pi over 6 cut in half. Now, my formula for the cosine was plus or minus the square root of 1 plus the cosine over 2. And so I have this plus or minus, the cosine of pi over 6 is root 3 over 2. And very similar to this last problem, we have this fraction and a fraction. So if I multiplied inside by the number 2, I would get a 2 plus a root 3 under this root. And 2 times 2 is 4, but the square root of 4 is 2. And then we do want to remember that since this was in the first quadrant, I'm going to assign the positive side of that angle. But keep in mind, I was looking for the secant, not the cosine. So I'm just going to flip that thing over. And like I said, this is kind of an ugly looking answer, but that'll be okay. I'm just going to leave it like that and call that information good enough. Now, in a similar way, just because I think that I should probably take a look at one of those, imagine that instead of looking at some of those, what if we were looking for, let's say, a tangent And so if I was looking for, let's say, a tangent of 3 pi over 8, actually, let's go tangent of negative 3 pi over 8. Let's do that. So I'm going to, instead of doing this, I'm going to think about this as being the angle negative 3 pi over 4 cut in half. And so my formula for this, and again, I have multiple options. I have this one and I have this one. And so because this denominator, I think they're both going to be ugly. So I'm going to go with this one because at least it has less information. So I'm going to go with 1 minus the cosine over the sine. And again, I'm going to be using the angle negative 3 pi over 4 because that's what I was cutting in half. So that leads me with this answer right here. The cosine of negative 3 pi over 4 is actually negative root 2 over 2. That's from the simple unit circle. The sine of negative 3 pi over 4 is also negative root 2 over 2. So doing just a little bit of cleanup, I'm going to multiply everybody by 2. So I'd get 2 plus root 2 on top. Notice the double negatives. And divided by negative root 2. And we could stop there, but kind of cool because I could divide these. 2 divided by root 2 is root 2. And root 2 divided by negative root 2 is negative 1. And that would be even the best answer that I could possibly come up with. And that kind of takes a quick look at how we can kind of figure out where things are. And you'll notice that I didn't have to do the whole plus or minus in this one. It automatically takes care of itself. And again, I could type in the tangent of negative 3 pi over 8 if I wanted to, and type in this answer or this answer and see that I got exactly the same decimal. So hopefully that helps give you a little bit of an idea on how to take a look at double angles when it kind of refers a little bit to the unit circle. All right, I'll see you back in class.